Hello, this video is to walk you through the early steps of the electrophoresis makeup lab. So you're going to click Start Simulation and choose Level 3, and you're going to read the context materials, you can make a prediction, then we're going to go to the protocol. So meet me there, and you click Next Section to go to the next section. So read the context, and I will meet you there. So these are the steps we're doing. I got into some trouble in these steps because you have to open and close, and I want to do the fast way because this is a simulation, but this actually does a really good job of taking you through what each step of electrophoresis would be. So follow the protocol here, and one thing that it doesn't say, place gel into box, well, you have to open the box like so, place the agarose gel, and then you need to rotate it so it goes the right way. This is the anode, it's the negative charge, this is the cathode. So we're going to want the wells close to the anode because DNA is negatively charged. It's going to run away from this end and be attracted to the cathode. So I'm going to click on that, and of course, it's in backwards. So I want the wells close to the anode because DNA wants to go to the positive end. If you do it the other way, it's a really fast gel. Then click Close. You're then going to have to centrifuge these three samples. So you open the microcentrifuger, you drag them in, and you have to balance it. So I can actually put the other two here and here. If I only wanted two, I would balance this by having them on these two ends. So whenever you run a centrifuge, things have to be on opposite sides, and I'm only going to do two because I only want to load two of them. I would like you to do all three. So close it and close the lid, then click on this to run it. And this unfortunately is set for minutes. And it wants you to spin them, I guess 30 seconds. These unfortunately are real seconds. So I'm going to press start and then stop the video. And then it wants me to put them back on the rack. So solution 1 is the one we didn't use. So I'm going to put solutions 2 and 3 on the rack. So remember, we're not using this one and I want you to use it. I just want to make it go faster, so I didn't use it. Now we need to put a buffer in here. That's going to help carry the electric current from the anode to the cathode. So you just pour that in. Ta-da. So I want to change the micropipette to 20 microliters. So I'm going to select my P20. See, it's only at 2 microliters. So my first time I thought it was set right. So this is going to turn it, remember, tens place, ones place, decimal place, and I want this 100. So I will pause again while that happens, and I'm going to click Save Volume to be safe. Now I have to open the box, put my tip in place, so go over here. Now again, I said there's a lot of opening and closing, so I'm going to open 2 and 3. Remember, I didn't spin 1, so it probably won't work. I will go here, and I have to hold on to it to go the, oh, I screwed up because I want 2 stops. So just go over here, trash it, eject tip, get a new tip, go here, and then this time only press it down once and let go. Then I drag it over here, just got mad at me, select well 2, click next, press it down once, and for some reason it doesn't want you to go 2 stops, so only go 1 stop. You repeat this for the 3rd sample. You go over here, you eject the tip, go grab a new tip, and this is all things you would be doing in this lab face-to-face. Press it down once, drag it over to the gel, select that one, click next, press it down once, and we're not going to overflow it this time, and then close. Now, eject the tip, put your tools back in place. Oops, close. Close the electrophoresis box, and we need to attach the electrodes. So I thought this was a little funky, actually getting it in the right place. So I guess that's in. See, it'll get mad at you if it's not connected. So I'll do the N. I will do the cathode now. That's the anode. All these instructions are right here. So I'm going to get to the power supply. So turn the power supply on. That's that button. On. Set the voltage to 130. This is going to take a while, but I use this button. Set the timer for 10 minutes. Again, by this button. Start the timer, and then wait for this elapses. Fortunately, it is seconds, not minutes. And we're done now, so we'll close that. We'll unplug our electrodes. Oh, we have to turn the power supply off first. I've done that each time I've tried this. So see, it tells you when you're doing something wrong. So we're going to unplug this. Oh, we really need that in the real lab. Open the box and inspect your gel. Inspect, I lost the page, I can't go back. To inspect your gel, you actually have to click on the next button right there. So see how there's a next button, I have to click on that. But I'm not going to show you the results because I want you to take a picture of it. Mac users, it is Command-Shift-3 to make a screenshot. PC users, it is Command Print Screen. And just so you know, when I taught online anatomy, I got a lot of screenshots of just using a phone and taking a picture of the screen. That is perfectly okay. I forgive you. Now, I also want you to tell me which is the smallest and which is the largest of them. This one's the largest. These two are the largest here because they went the least amount from where our wells are. So here are our wells. Those are the largest because they went the least. They ran to the most resistant. These are the smallest because they went the furthest. And it's going to be something like that. It's using food coloring. So here's an actual gel. It's the last gel I ever ran. I gave bacteria the gene presenilin-1, which is responsible for Alzheimer's if it is wrong, and the gene beta-actin, and I might have also given it antibiotic resistance and phosphorescence, but that's beside this point. So this one, the presenilin-1, is a smaller gene. It went farther than the beta-actin, which is this one. So colony 1 picked up the presenilin, colony 2 picked up the beta-actin, and colony 3 picked up both. Colony 3 is my hero here because it got both genes. So that is what we are doing for this lab. Thank you.